I would like to thank all of you for joining this Yellow Belt training, and I hope that all of you will have a wonderful learning experience. So I'll just start with a quick recap about my introduction, and then we will start. So my name is Annamalai. I am basically a BTech engineer from IIT Varanasi, Banaras Hindu University, and I passed out in the year 1985. And for 30 years, I was in employment, both in Murugappa Group in South India, Chennai, and also the Siemens in near Calcutta. And for the last 10 years, I am running my company on my own. And we focus on the customized content development, training, and the project support, implementation support for lean management, Lean Six Sigma, and project management. So we have worked with multinational companies like Amazon, Asian Paints, SLR, ESAP, Lennox, and so on. And I also have the training experience for the Tata Telecommunications, L&T Valves, Standard Chartered Bank, and Pfizer Healthcare, and so on. So that is a brief introduction about myself and my company. So we'll now get started with this Yellow Belt training. Okay. So we know that what is a problem, right? So a problem is an obstacle which makes it difficult to achieve a desired goal, objective, or purpose. So in all our professional lives, we are always given target by our management, right? What we call as a KPIs, key performance indicators. So in terms of the yield, in terms of downtime, in terms of the productivity, and so on. So always we are under tremendous pressure from the senior management to just achieve the targets. And many times we just face some unexpected problems. So in terms of some manpower issues or machine related problems or material related issues, and then most often we just fail to achieve the target, and we are always under pressure. So the problem is a situation or a issue that is not yet resolved. And problem solving means any problem will have one or many solutions. So whenever we have a problem, we try to explore what are all the possible solutions. So we just do a brainstorming session with our peers and our subordinates, and then try to find out some root causes. And then we try to just again brainstorm about what actions we can take. And then we take action, and whatever the best solution we think, then that we implement. And that is what we call as a problem solving, right? So problem solving means out of the different solution, we will always try to select the best one and try to implement and solve the problem. So whenever you are solving the problem, then depending upon the complexity of the problem, again, we can use the different methodologies or different approaches. So that's what we are trying to learn now. So whenever our problems are simple in nature, then we just to do it. So the problems, so these problems don't need any uh, deep analysis into the problem. These are all some common sense solutions, right? For example, when you walk across site from the raw material inspection area to the final quality control and inspection area across the entire process area. So we'll always find that at some places, maybe some air is leaking, somewhere else water is leaking, somewhere else the material is getting wasted, somewhere else somebody is doing some rework, somewhere else the machine is remaining idle or under repair. So right from the raw material storage up to the finished goods area, we find that a lot of problems are there. So out of these many problems, we can just solve it just by noting down, okay, this is the problem, and then this is the action to be taken. So no need for you to do any deep root cause analysis and all. These are all common sense solutions. So that's what we call as a just to do it. So in a Six Sigma language, we call this a Gemba walk. So we do a Gemba walk. Gemba in Japanese term Gemba means it is a workplace. So we walk around the workplace with a open eyes, with an open mind. Then you will be able to find a lot of problems for which the solutions are quite obvious. So you list down the problems and then take the action, make an action plan, implement the action. Definitely, immediately you will get some improvement. So that's what we call as a just do it. So whenever you are trying to learn about this particular problem solving tree, so imagine that you are entering a orchard, which is having a lot of fruit bearing trees. And your aim is to just eat the tasteful fruits. So when you are entering the orchard, you are finding that already a lot of fruits are fallen. So only thing is you need to just bend a bit and then you'll have to pick those fruits and then eat it without any effort. Then just bend it and then you'll be able to eat those fruits. So similarly, just by looking at the problems with the open mind, you will be able to identify and solve some problems. That's what we call as a just do it. Then we call as a quick wins, also called as a low hanging fruits. So somewhere you find that there are some low hanging branches are there. So just by stretching yourself a bit, then you will be able to just pick those fruits which are at the low hanging branches. So we call this a low hanging fruits or quick wins. So by using some simple problem solving tools like the Fishbone diagram or a Pareto chart or a scatter plot, then you will be able to analyze and solve those problems. So we call this a low hanging fruits are the quick wins. So this just to do it and the quick wins. So these two are useful for solving the simple problems, right? Whenever the complexity of the problem is simple, then we can use this problem. Only thing is we need to have a mindset. Then in order to solve the medium complexity problems, we can use the lean and AD. So lean is actually a methodology for identifying and eliminating waste in the process. So again, we are going to learn later in this session about what is lean. So again, there are 8 different types of waste is there. And by using some lean tools, which you would have already heard about it, like the 5S or Pokayoke or Kanban or Kaizen, you will be able to solve those problems. So that is one methodology we can use for solving the medium complexity problems. And 8D is actually 8 discipline report. So this is a methodology by which you just follow a structured methodology for solving the repeated issues. Right? For example, whenever you are sending your material to your customer, so you are finding that at one particular place, certain crack is coming, and it is not coming in all the parts, but only 1 or 2% of the parts. And this problem is not yet resolved even after 6 months or 1 year. So this type of repeated problems we can solve by using the 8D methodology. In IT service or a software development, we can also call this incidents management. So a particular server is frequently breaking down, or a particular tool is not running. So those type of incidents management we can solve by using the AD report. So for solving the complex problems, then we can use the Six Sigma methodology. And there are 3 different approaches what we can use. So generally we use the DMAIC methodology, that is define, measure, analyze, and improve. Define, measure, analyze, improve, and control. So these are the 5 phases of Six Sigma projects following the DMAIC methodology. So whenever we have a problem, we'll have to define the problem. So where is the problem? What is the problem? What is the extent of problem? We'll have to quantify the problem. Then what is the target we want to achieve? What is the scope of the project? Then you just identify what are the benefits you are going to get the project by solving the problem. Then you collect the lot of data from the process during the measure phase. Then you analyze the data with the help of the statistical tools and find out some 3 or 4 critical root causes. And in the improve phase, you take action only on those 3 or 4 critical root causes. And in the control phase, you put in some control mechanism in place so that you'll be able to sustain the improvement. So we are going to learn about that in depth in the following sessions now. So this DMAIC methodology is used for improving the existing process and existing product. So if a process is existing for more than 1 year and we find that the issues are repeatedly coming, then we can solve those problems by using this methodology. Then we have the DMADV approach: define, measure, analyze, design and verify. Design and verify. So we solve the problems by improving the design of the product or design of the process. So for example, if you're working for a automobile company like Maruti, and your competitor model is having a lot of customer market share, and when your marketing team analyze that it is because of their higher fuel efficiency, then you just take up a project to improve the fuel efficiency. Then maybe you find out what are the critical root causes which are contributing to the higher fuel efficiency, and change the design of your car engine. Then maybe you may be able to get a better efficiency. So by changing the design of the product or process, whenever you want to improve the process, we call it the DMADV. That means you are going to do the re-engineering of the current processes. And CDOB approach, that is concept, design, optimize, and verify. This methodology is used for developing a new product right from the scratch. For example, when you wanted to develop the electrical vehicles, right, electrical buses or electrical cars. So initially the concept itself was not there. So because that was entirely a new product right from the scratch, then you need to first develop the concept, then you have to design the product, then you have to optimize the product to give the best performance. Then you have to verify whether your design is right or wrong. And then you can just enter it to the market. So these are the three different methodologies in the Six Sigma, and these are used for solving the very high complex problems. So we call this a high hanging fruits. So high hanging fruits are always sweet, but again, it is very difficult to really pick it up, right? So these are the different methodologies or approaches we can use depending upon the complexity of the problem. So today we are going to focus more on the Lean Six Sigma, but not at a very high level, but at a very fundamental level. That is the yellow belt curriculum we are covering today. So we will just learn about what is an overview of Six Sigma. What is Six Sigma? So for this, I would like to tell a story from Mahabharata, one of the greatest epics of India. And one day, Guru Dronacharya, who was teaching the war-related skills to both the Kauravas and Pandavas, he called all of them to a river bank, and on a tree, in the river bank, he placed a bird made of clay. And the target given to all his students was that they should hit the bird in one arrow. So first came Duryodhana, the eldest of the Kauravas, and when he started taking the aim, the Guru asked him, "What are you doing? What are you seeing?" Then Duryodhana told that he is seeing the bird. Again the Guru asked him, "What else are you seeing?" Then Duryodhana, he wanted to impress the Guru, and then he started telling that I am seeing the tree behind, I am seeing the river behind, I am seeing the forest behind, I am seeing the mountain behind, and so on. Again, the Guru checked whether he was holding the bow properly, whether he was taking the aim properly, whether he was taking care of the breeze that was passing at that point of time. He was not convinced about his the process and the inputs of Duryodhana, and he got them to quit even without making an attempt. So like that, one by one, all the Kauravas and Pandavas came, and when they were taking the aim, the Guru was asking the similar questions, and the disciples were giving similar answers, and the Guru asked them to quit even without making an attempt. Last came Arjuna, the most favorite disciple of Guru Dronacharya, And when he started taking the aim, again the Guru asked him, what are you saying? Then Arjuna told that I am seeing the bird. Again the Guru asked him, what else are you saying? Then Arjuna told that I am seeing the eye of the bird. Again the Guru asked him, what else are you seeing? Then Arjuna told that I am seeing the eyeball of the bird. Again the Guru checked whether he was holding the bow properly, whether he was taking the aim properly, whether he was uh, taking care of the breeze that was passing at that point of time, and whether his bows and arrows were made of good quality material. And once he was satisfied that Arjuna's inputs were right and his process conditions were right, then he was 200% confident that Arjuna will hit the target, and he gave approval to Arjuna to hit the arrow. Then Arjuna took the aim, then he just shot the arrow, and the arrow went and back, hit the eyeball of the bird. So even though this story is a few thousands of years ago, then the moral of the story is holding good even in the modern day today, what we call as a process approach, which is one of the basic principle of Six Sigma. Before trying to understand what is process approach, let us try to understand what is a process. So a process is a set of activities done to convert the inputs into outputs. So in manufacturing, we take some raw materials and then we process the raw materials by using some machineries under some process condition. And finally, we get the products what we are trying to make, either the automobile components or electronic components or plastic components. So similarly, whenever we are working in the IT service or the software development companies, then we collect some information as a raw material, raw input. This information we process under the various tools and techniques, and then finally we get the required output in the form of some reports or in terms of some software, etc. So the inputs is converted into outputs by a series of processes. So that is what series of activities. That is what is a process. For example, let us take the case of a digestion process. So in the digestion process, the input is the food what we are taking. So the food is processed in the various organs like the mouth, the tongue, the teeth, the food pipe, the small intestine, large intestine, stomach, kidney, and so on. And then finally, the output what we get is the energy. So the input food is converted into the output energy by a series of processes in the undergoing in our digestive system. So maybe one day you had some problem of indigestion. So you went to the doctor and told him that you have this problem. Then the doctor will start asking the questions like, what did you have yesterday? Did you have any outside food? So is this problem quite repeatedly coming? So where do you feel this problem quite often? So like that. So he is trying to understand what is the problem in the inputs or your process condition. Then you may remember and tell that, okay, 2 days ago, you had some pizza in an outside restaurant, and only after that, you have this problem of indigestion. So immediately, the doctor will analyze that the problem is because of the outside food you had, and then he will give the medicine accordingly. And once you take the medicine, then your problem of indigestion is going to be solved. So similarly, whenever you have any problems in your processes, so we have multiple problems in our outputs, right? So we always have a low productivity, we have the yield issues, we have issues in on-time delivery. So we are always under tremendous pressure from our senior management to address those issues. So in our endeavor to solve the problems in the outputs, we seldom have the time to analyze what are the problems in the inputs and process condition. So we just call some 3 or 4 of our peers or subordinates and then try to find out with whatever the data we have, we try to figure out what may be the reason. Then we just again do a brainstorming session and then arrive at some 4 or 5 action point, implement it. So for the time being, the problem seems to have been solved. But again, after 2-3 months, again the same problem will come and haunt us because the uh, root causes have not been identified properly and the permanent solutions have not been taken. So the process approach says control the inputs, control the process conditions, output will always be consistent. So again, I will write it for you. Control the inputs, control the process conditions, output will always be consistent. So this is what Guru Dronacharya was trying to assess with his disciples. With all his other disciples, he was finding that either their inputs were not right or their process conditions were not right. But with Arjuna, though his inputs were right and his process conditions were right, and he was 200% confident that Arjuna will hit the target. So whenever you have the problems in the output, don't bother too much about that. Try to analyze what are the problems in the inputs and process condition. Take action, then your problem, you'll get a consistent product. So that is what is the process approach, which is one of the basic principle of Six Sigma. The other basic principle you need to understand when you want to learn about Six Sigma is about variability. So variability is simply a deviation from expectation, right? So in any process, variability is inevitable. So whether it is a manufacturing process or a service related process or a software development process, any process variability is inevitable, right? For example, you see the height of the adult human being. So again, the height may vary from maybe 140 centimeters to 220 centimeters. You take their weight, maybe it may vary from maybe 50 kilograms to 120 kilograms, right? So the body temperature, again, it may vary from say 98 degrees centigrade to 99 degrees centigrade. So the ambient temperature, the humidity, everywhere the variability is always there. So that is inevitable in any process. So this variation in the output is caused by the variations in the inputs and process conditions. As we have just now learned, any output is influenced by the inputs and the process condition. So whenever we are finding the variation in the output, so that means there is a variation in the inputs and the process condition. So sometimes the variation in the process is becoming too large so that we start producing the defect. So I'll just give a small example. So let us assume that we are taking a 11 millimeter rod and we are grinding it to 10 millimeter, and the customer is willing to accept 10 plus or minus 0.5. That is 9.5 to 10.5. So initially your process was running good and you are always getting between 9.7 to 10.3. So you are very happy that you are getting 100% deal. But suddenly one of the bolt in the machine broke. Because of that, the vibrations in the machine started increasing and the variations increase. And because of that, now we are producing from 9.2 to 10.8. So that means whatever you are going to produce from 9.2 to 9.5, so that is going to be less than the specification. And whatever you're going to produce from 10.5 to 10.8, again, that is going to be more than the specification. That means your process has started producing the defects, not acceptable to the customer. So the Six Sigma will help you to reduce the variation in the output by reducing the variations in the inputs and process condition, and reduce the defects by reducing the variation in the output by reducing the variations in the inputs and process condition. Second, I will write it for you. The Six Sigma helps you to reduce the defects. So how does it help in reducing the defects? By reducing variations in the inputs and process conditions, variations in outputs. So how do we reduce the variation outputs? By reducing variations in inputs and process conditions. So for a process which is running at a Six Sigma level of the process capability, then you are going to produce only 3.4 defects per million opportunities. So that means you consider that we call the DPMO, defects per million opportunities. So you consider the aircraft landing is a process. So across a month, across the globe, maybe 1 million aircraft landings are happening. So out of these 1 million landings, only 3 landings are going to be defective. So such low is a defect rate when a process is running at Six Sigma level. And that is the reason why most of the companies, they want to implement Six Sigma in their organizations. So this is a typical graph you will get when you do a Six Sigma project. So this result we got when we did a Six Sigma project for reducing the scrap in a process. So before improvement, the average scrap was very high at around 21%, and the variation was also quite high. So the variation was from 15 to 25%. So a lot of variation was there, and the average scrap was also quite high. But when we did the Six Sigma project, then we analyzed the root causes for the problem, and then we took action. So that after the project was completed, we can see there's a drastic reduction in the scrap. Average scrap is now reduced from 21% to only 8%, and the variability also has tremendously reduced. So this is a typical graph you'll get after completing a Six Sigma project. So now let us try to understand what is Six Sigma. So it is a data-driven, structured statistical methodology to achieve the defects per million opportunities of 3.4. So it is a data-driven approach. So whenever you want to do a Six Sigma project, then you collect a lot of accurate data from the process. And this accurate data, you are going to analyze with the help of the statistical tools. And then you are going to find out the critical root causes. And then you are going to take action on those critical root causes so that you will be able to get a very low defect rate. So it is a structured methodology. So again, the structured methodology, that's what we have learned in the previous slide. So one of the method was DMAIC methodology, define, measure, analyze, improve, and control. Right? Structured methodology for process improvement. So it was first implemented in Motorola. So Motorola was a US company. They were facing a lot of competition between by the Japanese giants like the Mitsubishi and Toyota and so on. So they were getting a lot of competition from them. And then in order to face the competition, then they went for a new methodology, and then they came out with the Six Sigma. And after seeing the success of this methodology in Motorola, Allied Signals and General Electrical, they also implemented Six Sigma in their organization. So it was no new inventions were made. It was not that because of Six Sigma, a lot of new tools and techniques or methodologies were developed, but it was only the consolidation of the existing tools and concepts. For example, the PDCA cycle, the Plan, Do, Check, Act. So this methodology was in existence even during the 1950s. The control charts was there existing from the 1920s. The design of experiment, which is used for optimizing the process condition, that was in existence even during the 1940s. So the Motorola, the two of the key people, Bill Smith and Michael Harry, these are the two key people who are involved in coming out with this methodology. Then they worked hard, and then they came out with consolidation of whatever the best tools that can be used for analyzing and solving the problem. They just bundled it in the DMAIC approach, and then they rolled out as a Six Sigma methodology. So it was only the consolidation of the existing tools and concepts. So you can consider Six Sigma as a tools kit box for solving the process problem. So like how an electrician or a plumber or a carpenter is having tools box from which he'll be able to, by using those tools, he'll be able to analyze and solve the problem. So similarly, as a Six Sigma expert, you are going to be exposed to a lot of tools and techniques. So by using these tools and techniques, you'll be able to solve the process problem. So for any Six Sigma project, there are two major driving forces, the customer satisfaction and financial benefit. So any Six Sigma project will be taken up to solve the problems what the customers are facing because of our quality, price, or delivery. And since it is a very elaborate methodology, then a substantial financial benefit is expected so that the methodology can be affordable. So now we will learn about what are the different activities we do in the DMAIC methodology, which is used for improving the existing process and products. So if a process is running for more than 1 year and we are finding that variability is an issue, means one day the process is running very good, so the yield is 99%, and within the next week we find that suddenly it is dropping to 80%. So a lot of variation is there, and this process is running for more than a year. Then those problems we can solve using the DMAIC methodology. So in the define phase, we just start with the identify the customer who is having a problem with our quality or delivery or the on-time delivery, right? Quality or on-time delivery or price. And then we link it to the measurable metric. For example, if the customer is talking about the delivery issue, then how we are measuring the delivery performance. So we are measuring the delivery performance in terms of percentage on-time delivery. So delivery issue. So we are linking it to percentage on-time delivery. Then we measure what is our current performance. So current performance is only 80%, whereas what you have agreed with the customer is 95%. So we want to improve from the current state to what we have agreed with the customer. There is a big gap is there. So we will take that as a Six Sigma project. And then we make a document which is called as a project charter. So the project charter is actually one of the major deliverable in the define phase of the Six Sigma methodology. Then during the measure phase, we collect a lot of data from the process, and we just also measure the process capability. So what is the current level of capability of the process? Then during the analyze phase, whatever the data we have collected during the measure phase, we analyze with the help of the statistical tools, and then we just narrow down the top 3 to 4 critical root causes, which are contributing substantially for the problem. So determining the 3 or 4 critical root causes and validating with the statistical tool is one of the unique feature of the Six Sigma methodology. So none of the other problem solving methodologies are using the statistical tools for process improvement. So during the improve phase, again we take action only on those 3 or 4 critical root causes. Improvement action we take. And then in the control phase, we closely monitor and control 1 or 2 critical root causes, either the input raw material conditions or any of the process condition, and then we'll be able to sustain the improvement. So this is what is a structured DMAIC methodology for the problem solving. So this is what we just now discussed. So in the define phase, we start with a tool which is called as the Fishbone diagram. Maybe some of you would have already known. So we do a brainstorming session and find out maybe 40 to 60 potential root causes for the problem. Then by using the various quality tools and statistical tools, we are going to narrow down to 3 or 4 critical root causes, which are validated by the statistical tools. And during the improve phase, we are going to take action only on those 3 or 4 critical root causes. And in the control phase, we are going to closely monitor and control 1 or 2 critical inputs or process conditions so that we'll be able to sustain the improvements. Okay. So again, we have seen that a Six Sigma is a structured methodology for problem solving. So one of the structure is about the organization structure. So you know that how a organization structure is very important for any organization. For example, you are in your company, you find that your attendance is not marked properly. Then you know that you should go to the HR executive and get the issue sorted out. So you have some problems in your machine, then you know that you should go to the maintenance engineer and write a service ticket, right? So whenever there is a problem, so if you have a proper organization structure, then you will know to whom you should go so that the problem can be solved. So similarly, in an organization where you want to implement a Six Sigma, so whenever you have the process, the project managers and the project team members, whenever they have a problem, then a parallel Six Sigma organization structure is in place so that they will know to whom they should go so that the problem can be solved. So that's what we are going to learn. So the topmost, the highest responsible person is the executive leadership. That is the CEO or the managing director. So his role is very important in an Six Sigma, in an organization to drive the Six Sigma initiative. So he has to have a very strong leadership skill. So he has to give the overall direction for this Six Sigma initiative, and he has to arrange for the training at all levels of the organization, and he has to give a stretched target to all the functional heads who are reporting to them, so that they will be looking for some methodology or help for the achieving the target. And if Six Sigma is offered as a help for achieving their target, then they will immediately go for that. So that is the responsibility of the executive leadership. Then comes the role of the champion or the sponsor. So the champion or the sponsor is a person from senior management who is directly reporting to the managing director. So his main role is to provide the administrative support for the project. So he is responsible for selecting the Six Sigma project and the project team leader, project team members, and then he has to provide the resources in terms of material, manpower, and machine time for doing the project. And he is also responsible for avoiding any roadblocks, whatever the team is going to face. So how to overcome those roadblocks? Again, it is his responsibility. Then comes the role of the master black belt. So the master black belt is a person who is going to give a technical guidance for the project. So when I say technical guidance, it is not that for a civil engineering construction company, he is going to give the civil engineering related inputs. So when I say technical, that means related to Six Sigma. So the master black belt is the person who is going to guide the team about what type of data needs to be collected from the process, then how to analyze the data, which statistical tool to use, how to interpret the data and analyze the result. So all those guidance will be given by the master black belt. Then the project teams will be led by the black belts and green belts. So the black belts are normally the middle level managers. Black belts are normally the middle level managers. Managers are senior managers having a strong leadership skill. So they can lead a small, they can lead complex projects to solve complex technical issues, and they can also lead projects needing some interdepartmental coordination. So they are exposed to all the complex statistical tools, and they will always be mentoring and uh, motivating the black belt team members. And next comes the role of the green belts. So green belts are normally the lower management, like senior engineers, assistant managers, and so on. So they can lead a small independent project in their own department, or they can be a part of the black belt project team, and they just support the black belts in their projects. So they are exposed to all the statistical tools in all phases of the Six Sigma, but not as complex as the black belts. Then comes the role of the yellow belts. So yellow belts normally they help the green belt or the black belt project leaders mainly for collecting the accurate data from the process during the measure phase, and then during the control phase they will just help the project leaders to closely monitor and control these one or two critical inputs or process conditions. The last one will be the white belt. So it is some sort of a awareness training given to all the employees in the department where the Six Sigma project is taken up, maybe 2 to 3 hours of awareness training. So you can see a parallel organization structure is in place so that whenever a Six Sigma project leader is having some problem, then he knows to whom he should go so that the problem can be solved. So that is about the very high level overview of Six Sigma. So Six Sigma is a methodology for reducing the defects by reducing the variation in the processes. And we follow a structured methodology called the DMAIC methodology, define, measure, analyze, improve, and control. And we also learned about the roles and responsibilities in a Six Sigma organization. So now we'll have a quick overview about Lean. So Lean was actually a methodology which was popular in Japan during the 1950s. So all of you are aware that the Second World War was fought between 1939 and 1945. And the war ended when United States of America, they just dropped the atom bombs on two Japanese cities, Nagasaki and Hiroshima. So after the war was over, then the Japanese people, they were working very hard to come out of their economical issues. And the US government, they felt morally responsible for the devastation in Japan. And they wanted to help the Japanese people. So they sent a lot of US experts from the various fields to help the Japanese people. So the quality gurus like Edmund Deming, then Joseph Jurong and Phil Crosby. So these people, they went quite often to the Japanese people, and then they helped them to improve the quality. So during the 1950s, then Toyota, they became very active in Japan, and they were the pioneers for implementing Lean. They were the pioneers in implementing Lean. So Lean is a methodology for identifying and eliminating waste in the process. And the core idea is to maximize the customer value. So when we want to learn about Lean, then we need to learn about what is value. So value means it is the change in shape or form for which the customer is willing to pay. For example, so if the car is being manufactured, so the customer is willing to pay for the painting. So the cost of painting is included in the cost of the car. But because of some miscommunication, there was a rework that has happened in the painting, and you cannot go and ask your customer to pay for that extra money, right? Because that is not adding any value to the customer. So the Lean, the core idea is to maximize the customer value while minimizing the waste. So you are going to give more features and functions to the customer, and you are going to do it with fewer resources, so that a lot of benefits the organization is going to get. For example, assume that currently your selling price is 100 rupees and your cost price is 90 rupees. So your profit that is equal to 10 rupees. But if you are going to implement Lean, then you are going to give more value to the customer. You are going to give more features and function. So he is willing to pay more. So assume that he is willing to pay 110 INR. That is the selling price now. And since you are going to do it with the lesser resources, then you are going to do it with 80 rupees. This is going to be the cost price. So that means your profit is going to be 30 rupees. That means 3 times your profitability has increased because of implementing Lean. So that is the reason why most of the companies, they want to implement Lean, right? So typically we find that in a manufacturing setup, only 25 to 30% of the time, whatever you are spending, is on the value-added activities, and around 75 to 80% of the 70 to 75% of the time, whatever you are spending, is on the non-value-added activities, also called as a waste. So by implementing Lean, we will be able to substantially save the money for the organization. So Lean will help to systematically reduce the cycle time, errors, inventory, and respond quickly to the customer. So like Six Sigma, Lean is also a top-driven approach. So a lot of initiative and push has to come from the senior management. So that is a very high overview about the Lean. So when we talk about Lean means identifying and eliminating waste. So whenever we talk about the waste, immediately what comes to our mind is the scrap what we are doing in the process. But again, that is not the only waste. So we are having 8 different types of waste. according to lean, and which can be remembered by remembering the word downtime. So where D stands for defects, O stands for overproduction, W stands for waiting, N stands for non-utilized talent, and T stands for transportation, I stands for inventory, M stands for motion, and E stands for extra processing. So now we will have a quick review about each of these wastage. So defects means any efforts caused by rework, scrap, and incorrect information. So if in the end-to-end process at the various stages of production or operation, we are scrapping the product or we are scrapping the efforts, whatever we are taking, or we are doing some rework, then we call this a wastage due to the defect. Any scrap and rework we are doing the process is classified as a defect. Overproduction is production that is more than needed or before it is needed. So without order, if you are going to produce and then keep it in the inventory, then that is called as a overproduction. So whenever we are producing something, we need to do it only if there is a firm commitment from the customer. So in order to avoid overproduction, we need to ensure that we produce only the right product. When I say right product, we should produce only the products for which we have the firm order from the customer. And so we should produce the right product at the right quantity. So if the customer is asking for 50, we should produce only 50. We should not produce 100, right quantity at the right time. So we should again produce only when it is at the time needed by the customer. So again, supplying well in advance or supplying late, that is not advisable. We should supply on time as required by the customer with the right quality. So always produce only with the firm order from the customer in order to avoid the overproduction. Third wastage is waiting. So whenever we are doing a end-to-end process, then we cannot expect that all the processes will have the same capacity. Maybe when we are doing a 3-step process, maybe the first step may be producing at the rate of 1000 pieces. Second process may produce only at the rate of 500, and the third process may produce at the rate of 750. So in that case, if all the machines are going to run continuously, then more and more inventory will get accumulated between. So a lot of material will be waiting in front of the process 2 because it is having the lower capacity. So any material waiting for the next operation, that is going to be a waste, and we call it a waiting time. The fourth one is about non-utilized talent. So when I have asked this question multiple times to my student, so what percentage of your time is being utilized by your organization? So they always come out and say that only 50 to 60% of their capabilities are being utilized by their organization. That means 40 to 50% of the employees' capabilities are not being utilized by the organization. So that is going to be a huge loss to any of the organization. And again, this needs to be tapped. So the Japanese companies are very good in utilizing this talent by taking some initiatives like the Kaizen and everything, so that they always keep their employees engaged in their work in order to. So the employees will always be thinking about how to improve the productivity and quality, so that overall they also will be benefited and the organization also will be benefited. So engaging the employees and making them to encouraging their ideas to be implemented. So that will form a part of this particular wastage. Next one is about transportation, mainly because of the logistics or the layout. So zigzag movement of the material may result in the rejections and a lot of wastage of power and fuel. That is going to be a huge wastage. Inventory. So inventory is the biggest enemy as far as the lean is concerned. Any material or any work which we have already added to the product or service, but you have not been able to convert it into money, and that is lying as a raw material inventory or a work in progress or a finished goods inventory, then the cash flow is going to be affected seriously, and we will not have enough money to pay to our suppliers and salaries to the employees and so on. So reducing the inventory as much as possible is one of the important aspect of lean. Inventory is one of the major wastage according to lean. Seventh waste is about the motion, unnecessary movements of the people. So, for example, if an operator has to bend a bit in order to load the machine, and he has to stretch a bit in order to unload the parts from the machine, and he has to walk some 50 meters to transfer the material to the storage area. So this bending, stretching, and walking is going to make him tired too much, and then his efficiency is going to be reduced. So that is the wastage due to the motion. So again, we have to give a proper working environment to the employees. So they should be made to work. Maybe if the people are made to work where there is a lot of noise is there, or a lot of heat is there, or a lot of dust is there, a lot of sound is there, then or they are asked to take some heavy, lift some heavy weight. So these are going to make them very tired too soon, and then their efficiency is going to be reduced. So we'll have to give the proper working environment and working tools to the employees to come out of this particular wastage. And the last one is about the extra processing. So extra processing is doing some process more than what the customer is looking for. So if you are going to do the double time quality control, or if you are going to do some activity which is not actually adding value to the customer, we call it the extra processing. So in our processes, we need to understand where these 8 types of waste is there and take action to reduce this, so that overall our efficiency will be improved. So again, there are many lead tools are there. So I have just listed down only some 5 most commonly used lean tools. So we'll just have a quick look at these tools. So Kaizen is maybe some of you would have already heard about it. So Kaizen is actually a Japanese word. It is the meaning for continuous improvement. So when we talk about Kaizen, we are talking about small improvement. So we are not talking about a breakthrough improvement through the Kaizen. Maybe improvement in productivity by 1% or a reduction of errors by 0.5% and all. So whenever a employee has got some ideas, then he can just write that idea in a format, and then he can give it as a suggestion scheme. He can give it as a suggestion to the management. Then the concerned manager will review the idea, and then he will give the approval. And once he gives the approval, then it will be implemented by the employee. And then maybe every month or every 3 months, the best ideas can be, the person doing the best ideas can be recognized and rewarded. And again, the monetary value of the reward is not going to be very, is not going to be great. But the fact that the reward is being given by the topmost person in the organization in front of all the employees, that is going to be a motivation factor for all the employees to go for it. So Kaizen means it is a small improvement. And Pokayoke is mainly used in the control phase of the Six Sigma project, and mainly used for mistake proofing. So whenever we are doing some manual work, always there is a possibility that we may do some manual mistakes, and then that may again have a major impact on the process. So by doing a Pokayoke or a mistake proofing, for example, I will give you some. So Pokayoke means we are going to put in some foolproof system in place, so that even if somebody wants to deliberately make a mistake also, the system is not going to allow him to make the mistake. So that's what is the Pokayoke. So it's a mainly for avoiding manual errors. The low cost automation. So I'll give you some 1 or 2 examples so that you'll be able to understand. For example, when you get into a car and you forget to secure the seatbelt, and you start the car, after moving for a few meters, then you will get an alarm indicating that the seatbelt is not secured properly. Until unless you secure the seatbelt, the alarm is going to continue. So this is an example of Pokayoke. So similarly, when you open the microwave oven, when it is in a switch on condition, then it will automatically switch off, because the manufacturers know that if somebody is opening the machine when it is in the switch on condition, it is injurious to their health. So the design of the machine is done in a such a way that as soon as you open the machine, then the machine is going to be switched off. So After making the improvement in a Six Sigma project, you will have to put in some control mechanism or Pokayoke mechanism in place in order to sustain the improvement. And 5S is actually a lean tool which is mainly used for improving the workplace discipline. And in a company where you want to implement lean or Lean Six Sigma, always it is better to start with 5S. Because until and unless the people, the workmen and the supervisors and engineers, they have a proper workplace discipline, then you will not be able to sustain the improvement. So 5S is coming because of the 5 Japanese words starting with S. Seiri, Seiton, Seizo, Seiketsu and Shichuke. So Seiri means sorting. First we'll have to sort out what is required and what is not required. Not required items has to be removed from the place. Then whatever the items you are keeping as required, we'll have to set in order. So we'll have to systematically arrange it. So that means a place for everything and everything in place. So for each item what we are keeping, we have to find a suitable place, and that item has to be at that place only at any point of time. So that is what is the setting in order. Then shining. So we'll have to clean the workplace, clean the machine, so that we'll always help in reducing the any accidents or any downtime. Then fourth is about standardization. So whatever we are doing the work processes has to be standardized. Even if any different people are coming and working, then they should be doing the activities in the same way so that the quality is going to be consistent. So that is what is the standardized. Last one is about sustain, mainly for self-discipline. So whatever the benefits you are going to get, so we should be able to sustain. So these are the 5 S's, which is mainly coming from the 5 Japanese words, Seiri, Seiton, Seizo, Seiketsu, and Shichuken. The next tool is about Kanban. So that is actually a visual management tool for inventory control. So whenever you want to control the inventory within a minimum and maximum level, then you can use this tool. And just-in-time concept is mainly used by the car assembly companies. So they will always, if the company has got a capacity to produce, assemble 1,000 cars every day, then all the materials will be allowed inside the factory only at 6 a.m. in the morning when the first shift begins. Then at the end of the day, all the 1,000 cars will be delivered out of the factory. So there will not be any inventory either at the raw material stage or at the work in progress stage or at the finished goods stage at the beginning and ending of the day, so that the inventory is going to be the minimum and wastage is going to be reduced. So this concept is mainly used by companies like Toyota. So that is about some high level information about what is lean, what are the 8 different types of it, and what are the most commonly used lean tools. So now we will quickly go to the different topics, mainly for the yellow belt. So as I told you, like the yellow belts will help the project leaders to collect the accurate data from the process during the measure phase. And again, they will also help the green belt or the black belt project leaders to control the critical inputs in a very narrow range during the control phase. So now we'll learn a bit about the define phase. So the define phase, we just try to identify what are all the problems you are having. So we just try to find a list of some 10-15 problems, and then we try to find out which is the biggest problem. So in order to prioritize the problems for the solving, then we can use the tool which is called as a Pareto diagram. So the Pareto diagram or a Pareto chart is a tool which will help in prioritizing the root causes for immediate action. So this word Pareto is derived from Vilfredo Pareto. So he was an Italian economist who lived from the 1848 to 1923. And he told that 80% of Italy's wealth was distributed among only 20% of Italians. So that means very few Italians were owning a lot of Italy's wealth, and the wealth distribution was not very uniform. And this concept was also called as the 80-20 rule. And Ishikawa, the Japanese quality guru, then he told that this concept can be used for problem solving. And he told that 80% of the impact of the problem, 80% of the impact of the problem are caused by 20% of the causes. And if you are able to solve those 20% of the causes, then 80% of the problem is going to be solved. So again, I will explain this concept by giving an example. So assume that you are working for a IT support company and you have a tool, issue management tool. So whenever you have any hardware or software issues, then you can log into the tool. And somebody from the IT support team, they will just attend to that. And once you confirm that the issue has been resolved, then they will close the ticket. So then, they wanted to, the management, they wanted to reduce the manpower in the IT support team. So a project was taken up to just reduce the number of tickets to be raised. So maybe in the system, a ticket can be raised because of 20 possible causes. And on an average, around 1,000 tickets were raised every month in that company. So according to the Pareto chart, then 80% of the impact of the problem, that means 80% of 1,000 tickets are caused by, that is 800 tickets are caused by only 20% of the causes. That is 20% of 20 causes. That is equal to 4 causes. So 4 causes are contributing to 800 tickets. And if you are able to identify and resolve those 4 causes, then 800 tickets are going to be resolved. So here you can see that the mouse issues, keyboard, and the unable to install software. So these 3 were itself are contributing to 85% of the problem. So if you are able to solve these 3 problems, then majority of the problem is going to be solved. So the Pareto diagram will help you to narrow down the scope of the project during the define phase of the Six Sigma project. So again, whenever you do the define phase, again the project charter is one of the very important deliverable, as I told you earlier. So the project charter, we need to define what is the problem we are facing. So we need to clearly define what is the problem we are solving. For example, we can say that the problem is that currently the percentage on-time delivery is slow at around 80%. So very simple. So we need to identify what is the metric we are taking for improvement, what is the current status, and how long the problem is existing. And goal statement should say what is the target we want to achieve and by when. And for example, the goal of the project is to improve the percentage on-time delivery from 80% to 95% by March 2026. That will be the goal statement. The business case is the justification for taking the project. Why you are taking the project and what are the problems you are going to take if you are not going to do the project, and what are the benefits you are going to get by doing the project, right? So that we written in the business case. Then the timeline. So the start and end date for each phase of the DMAIC methodology. Scope of the project. So what processes are in scope, what products are in scope, which customers are in scope, and which customers or product are out of scope. So that we define the scope. Then the team members. So who is the project leader? Who are the project team members? Who is the master black belt champion? So all those will be listed in the team members. And then the project charter is actually a formal document. So that will be signed by the champion, who is one of the senior management person. So that will give a sense of importance for the project, since it is signed by the senior management person. So the project charter is one of the major deliverable in the defined phase of a Six Sigma project. So this is an example of a project charter. So I'll now explain a very small case study from my own personal life to explain how the DMAIC methodology can be used for solving a problem. So there was that happened maybe in 2004, the next year after I got certified as a black belt. So there was a first day after the summer vacation when my daughter had gone to the school, and when she came back, then I found that she was feeling very sad. So when I asked her the reason for her sadness, immediately she did not come out. But when I put a lot of pressure on her, then finally she told that she was feeling bad because when all their other friends were explaining about their wonderful experience in an exotic location during the summer vacation, she was not able to say anything, and that is the reason for her sadness. I was feeling even bad because I was the one who did not take her for an outside vacation, because even though I was earning around $120,000, I was for the last 5 years, I was not saving even a single penny. And so I thought, why this problem cannot be taken up as a Six Sigma project. So the define phase, I just started with the customer. So customer here is my daughter, and the problem here is about the inability to explain about go to the summer vacation. So the metric identifier for improvement is my saving. So the problem statement is currently the savings is 0% against the saving of 5% for the last 5 years. Goal is to increase the saving from 0% to 5% within 3 months. So if I do that, the expected annual saving is going to be $6,000, and the project timeline is going to be 3 months. So you can see that all the major elements of the project charter has been taken care. Then during the measure phase, then I had the data on how many $120,000 of the salary was spent in the different expense heads. So again, I use the Pareto chart to narrow down the scope of the project. So you can see that the rent was contributing around 31% of my expenses. Food was around 25%, shopping, etc. So again, the rent, food, and shopping, these were contributing to 70% of my expenses. Sort of which rent, I could not do much about it because my house was at a place that was the least rent area in that location. What about the food? We ourselves were surprised when we found that we are spending around $30,000 only on food. So we thought there is a lot of scope for reducing the food cost, and we wanted to focus only on the food expenses. So by using the Pareto chart, we are able to narrow down the scope of the project only to a specific item, that is the food. So once we decided that we will attack only the food expenses, then I had the data on how the $30,000 was spent during various months. So here you can see that the minimum was around $1,650 and the maximum was around $3,750. So a lot of variation was there. That means this is an ideal project that can be taken up as a Six Sigma project because a lot of variability is there in the process. Then in the analysis phase, I just did a fishbone diagram to find out what are all the possible root causes which are contributing to the higher food expenses. So I categorize into the primary food like the rice, wheat, bread, etc. Secondary food like the butter, fruits, vegetables, etc. Outside food, the ice creams and chocolates, restaurants, etc. And the snacks and beverages. So these are the factors contributing to the higher food expenses. Then again, I just use the tool which is called as the X-ray diagram, and then I was able to find out that prioritize the meat, restaurant, oil, ice creams, and chocolates. So these four were prioritized as the root causes for the problem, critical root causes for the problem. So in a typical Six Sigma project, we will be using the statistical tools for validating these root causes. But since it is a simple example I'm giving you, just with this help of the tool, I'm just saying that these are the four critical root causes. Then during the improve phase, I just take action only on these four root causes. So I reduce the consumption of meat from twice a week to once in a week. Previously, we were taking the meat both on Saturday and Sunday, but we now decided that we will have the meat only on Sunday. Reduce the consumption of oil from 4 liters per month to 2 liters per month. Reduce the number of restaurants to once in a week to once in 2 weeks. Previously, we were going every Sunday. Now we decided that we will go only every 2 Sunday. We reduce the consumption of ice creams and chocolates. So I think we will be giving you the recordings for this presentation, says the webinar. So no need for you to record it. The recordings will be provided to you. Okay, don't worry about that. So we reduce the consumption of ice creams and chocolate. So all these four actions resulted in an annual cost saving of around $6,000. Also, the health expenses also reduced from $5,500 to $2,000. So you can see that these four root causes were not only contributing to the higher food expenses, but since they were not good for the health, then they were also contributing to the higher health expenses. So when I reduce their consumption, then in addition to the food expenses, the health expenses also came down. So similarly, in your day-to-day life, if you do a project, Six Sigma project, and you want to improve the productivity, you will find that at the end of the project, your productivity also will improve, your quality also will improve, your customer satisfaction will improve, your employee satisfaction will improve. Multiple benefits you will get by doing a Six Sigma project. Then during the control phase, my current state, almost after maybe more than 15 years, so my annual saving has now increased to 10% of my salary for the past 5 years. And my expenses on the health and loan repayment also have come down drastically. So since I was saving more and more, then my loan commitments were coming down, and I was able to save, reduce my loan repayment commitment, and then that also has helped me to save more. So now every year I enjoy a vacation with my family in an exotic location, and most important all, I can see happiness in my daughter's face during vacation, for which I can never fix a monetary value. So the employee satisfaction, customer satisfaction, these are all very important for any organization. And by taking up Six Sigma projects, you will be able to solve the problem, and you will be able to satisfy your employees and the customers. So that was about the define phase, where we were able to clearly identify what was the problem. Then we really defined what is the target we want to achieve. We were very clear about what are the benefits we are going to get from the project. Then we are fixed a timeline when each and every phase is going to start. And we are also very clear about the scope of the project, right? We narrow down the scope of the project to have a great focus. And then finally, we are also having in the information about the team, who is going to be the project manager and the team, etc. So these are all the important factors in the define phase. Any question? Somebody raise a question. Hands. Any questions? Okay. So during the measure phase, then we need to collect the data from the process. So we make a detailed data collection plan, and then we just make note of what we are going to measure. So whether we are going to measure the temperature or pressure, or we are going to measure the productivity. So what we are measuring, so that we need to mention. Then what is the data type? So again, there are different types of data out there. So what is the data type? What is the operational definition? What is the definition of the metric? Because many times we find that the definition of the metric and the measurement of the metric itself will be wrong. Different people will be doing it in a different way, and then that is creating a problem, confusion. So we need to clearly define what is the metric, what we are trying to improve, and how we are going to measure that. So that we can do through the operational definition. Certification factor. So how we are going to present the data. So for example, we are doing a project to improve the productivity. So mission-wise, we can collect the data and show mission-wise whether there is a different, shift-wise, whether shift to shift, whether there is a different, or gender to gender, male and female, whether there is a difference in productivity. So how we are going to stratify the data so that we will be able to get some useful information. Then sampling nodes. So are we going to collect the data on the entire population or only the samples? So if you are going to collect the data only from the samples, then how many samples you are going to take and how frequently we are going to take the sample. So that we need to define in the data collection plan. Then who and how, who is going to collect the data and how they are going to collect the data. So we need to make a detailed data collection plan, and then we need to start collecting the data. So in the define phase, in the measure phase, again, you'll be learning about some basic statistics like the measure for central tendency. So how you are going to, because whenever you calculate uh, there are two parameters we need to measure on the uh, metrics, what we are trying to improve. The one is the measure for central tendency, where most of the data points are likely to fall. So I think you would have learned about in your school days, maybe 9th or 10th standard, to the mean, median, and mode. So these are the different measures of signal tendency. And the next one is about the measure for dispersion. So that will give an indication about how far the data is varying. So say for example, we are doing a process where we are keeping we want to achieve a target of maybe 10, and the customer has given a target from 9.5 to 10.5. So by measuring the mean, that is the average, we'll be able to know, like for example, we are getting a mean of 10.4. Then we know that we are far away from the target on the higher side. So that means we'll have to adjust our process conditions in such a way that the mean is going to be reduced to somewhere near to 10, so that the probability of getting the right products is going to be more. Because if the mean is going to be very high at 10.4, then there are a lot of defective parts are likely to be produced, which is going to be more than the upper specification, right? So by calculating the mean and keeping the mean nearer to the target will help you to reduce the defects. Same way, we have to also calculate the standard deviation with the measure for how far the data is varying. So the standard deviation has to be always lesser the standard deviation, so lesser is the variation. So whenever you are collecting the data in your process, then you need to measure these two values and always ensure that the average what you are going to get should be nearer to the target value, and the variation should be, that the standard deviation should always be lesser. So by calculating these two, we'll be able to control the processes and get the best yield. And in the statistical tools, you will also learn about the graphical tools. Right? So whenever you are collecting the data during the measure phase, and if you are going to present the data in rows and columns in an Excel sheet, then it is very difficult for the people to really understand what you are trying to communicate. But if you are going to present the data in graphical tools like a bar chart or a pie chart or a box plot or a histogram, then it will be easy for the people to understand what you are really trying to communicate. Because the human brain is tuned to absorb the information from the pictures very easily when compared to the information in the text format, right? So whatever the data we are collecting during the measure phase, then we need to know how we can present it in a graphical format. Second, there are the box plot. Say, for example, uh, assume that these are the output from the 4 different machines, and so we are getting the pictures like this. So this indicates, assume that now the target value is somewhere, this is what around 6 is the target value. That's what we want. And we have plotted the box plot, and we are finding that these are the output from the 4 different machines. So by looking at the picture, we'll be able to know that the machine 3 and machine 4, they are not producing correctly, because the average is very high when compared to the target value. Target is 6, whereas we are getting around 6.3. That means this average is very high. And for the first one, we can see the variation is quite high, right? But the second machine, we can see that the mean is also near to the target value, and the variation is also quite less. So out of these 4 machines, then we can conclude that the second machine is giving the best result. So this type of inference we will not be able to get if you are going to get only a set of data in rows and columns. So that's a very important aspect of the Six Sigma methodology. So whenever you are going to collect the data, you need to present it in the graphical format so that it be easy for the people to understand. And again, the histogram is again one of the graphical tool. Many of you would have seen this type of picture here. So that also will give an indication about how far the data is distributing. The scatter plot is actually another tool that will help you to check if there is a relationship between two variables. For example, if you are trying to find out if the age and the height of the boys less than 15 years old is having any relationship, then we can use the scatter plot and check whether there is a linear relationship. So, for example, this is the age and height, and the age is increasing, height is also increasing. Then we'll find that most of the points are on the line or nearer to the line. That indicates that there is a strong relationship between the age and height. So the scatter plot and the logs and whisker plot and histogram. So these are all some of the graphical tools used to learn, so that you'll be able to interpret the data in a right manner. So again, lastly, the control phase. So in the control phase, we are going to just put in some control mechanism in place so that we'll be able to sustain the improvement. So again, there are 5S we have already covered at a very high level. So SAID means sorting, what is required and what is not required. Not required items has to be removed. Setone, setting in order. So we'll have to, whatever we have kept as required, we'll have to find a place for each of the item, and every time the items should be there only in an orderly manner. Seizo means cleaning. We'll have to systematically clean the machine and the workplace. Seiketsu is sanitizing. Sanitize the work, whatever you are doing, so that even if different people are going to do the same work, then there will not be any difference or variation. Shitsuke is sustaining the improvement by doing the audits and recognizing and rewarding. So that is about 5S. And the Pokayoke, we have seen that the mistake proofing or mistake prevention. So we are going to put some low cost automated mechanism in place, so that even if somebody wants to uh, make a intentionally they want to make a mistake also, the system will not allow them to make a mistake. So we saw some examples like the seat belt not secured properly, and the washing machine or the microwave oven getting shut off when it is open in the running condition. So these are all some of the Pokayoke mechanism. So after making the improvement in a Six Sigma project, in order to sustain the improvements, then you will have to find out some Pokayoke mechanism in place. So finally, again, the control chart is again one of the means by which we'll be able to closely monitor and control the critical inputs. So if you remember, we have seen, I told you that in the control phase, we are going to closely monitor and control one or two critical inputs of the process conditions in a very narrow range. And we are also going to see whether we are getting a consistent output. So for that, we use a tool which is called as a control chart. Right? So the control chart, we are having the middle line and the upper control limit and the lower control limit. And we need to ensure that whenever we are plotting our measurements against the time, so the not even a single value should be outside the control limits. So that will give an indication that our process is under control and we are getting the right output. And finally, the control plan. So control plan is actually a plan that will help you to document what are all the different inspections and testing we'll have to do on the product and on the process, so that you'll be able to get a consistent output. So right from the raw material, once you receive the raw material, then how many samples you have to take, what parameters you should check, and what should be the specification of each of those parameters, how we are going to measure that. So, and then in each phase of the stage of the production, then what are the inspections you are going to do on the product. So you may be controlling the weight, or you may be controlling the dimension, you may be controlling the viscosity, or so many things. So what should be the specification in which these parameters should be controlled? And then the process parameters, like the temperature, pressure, vacuum, flow rate. So what are the inspections and testing you have to do on the product and on the process, so that you will be able to get a consistent output. That will be explained in the control plan. So I think we have got a very fairly good idea about how a problem is getting solved using the Six Sigma methodology, right? So we define the problem, we quantify the problem, fix the target, define the scope, collect the data, analyze the data with the statistical tools, determine the 3 or 4 critical root causes, validate those 3 or 4 critical root causes using the statistical tool, then take the improvement action on those 3 or 4 critical root causes, and then in the control phase, as we are running the production regularly, we are going to closely monitor and control these 1 or 2 critical inputs or process conditions, so that we'll be always getting a consistent output. So that is what is the basic philosophy of Six Sigma, right? Okay. So that's what I wanted to convey to you. So if there are any doubts or any clarifications, you can just ask me now. So I think once you get into the green belt or the black belt, then you'll be, so we normally teach with a real life example from your own process. We also take an example of a case study about a pizza making company where there are a lot of rejections. So how they were able to come out of the problem by using the Six Sigma tools and techniques that we'll be explaining. And you also will have an opportunity to identify a problem in your own area of work, and how by using these tools and techniques you will be able to solve the problem. So this Six Sigma methodology will always give you a leading edge when compared to your peer, um, your friends. So if you are going to get this certification as a green belt or black belt, then you are going to get a you are going to be more equipped in the problem solving and when compared to the others. Okay. So any problems or any questions, you can just ask me. Any questions? Okay then. Thank you all for joining this session. Yes, Sheikh Mohammed, any questions? Sheikh Mohammed, any questions?
No, sir. Thank you. No question.